Hello everyone. I'm making a video on how to calculate with moles, how to do mole calculations. I'm calling this video 13 since I hadn't made a video 13. Now I do. I'll post this as soon as I get home. So what you need to do this short video is your class packet. I'm going to recommend that you tear off this front cover of the class packet so that you have this mole diagram mobile, able to work with you as you work through problems. You'll also need your homework packet just to do a little bit of the homework that is supposed to be for tonight. I will be giving you this hard copy of the mole diagram that has a handy dandy periodic table on the back. I'll put this in materials exchange, but you don't need to come in just to pick this up, but you'll be able to get it anytime. Please have a calculator and a periodic table also. I'm going to share my screen to show you my slides on how to do mole calculations. All right. This is a video on how to do mole calculations. It really is a piece of cake after all that we've done with dimensional analysis and sig figs. Video number 13. My objective is to use the mole diagram and do some of the calculations in both the class packet and the homework packet. Since we're a little late doing these mole calculations, this is an important announcement. On the homework check on Thursday, I will not ask questions about mole calculations. That will be covered a lot on the test next week, but not on tomorrow's homework check. So here's the mole diagram that I want you to use all the time when you do these mole calculations. This mole diagram is showing you that the mole is a central idea, and it connects the volume of a gas, the mass of any substance, and the number of particles of a substance. To go between the mole and any of these other three steps, you need an equality. This equality is given at each step. To convert from moles to volume of a gas, the equality is 22.414 decimeters cubed, or liters, of any gas equals 1 mole. Now remember that an equality can be made into two conversion factors. To go from mole to mass, you need the periodic table. The periodic table is where you get the mass of 1 mole of any element. The molar mass is what the average atomic mass is. The average atomic mass is the mass of 1 mole of those atoms. Now, of course, if you have a diatomic element, then you have to double that mass. The mass on the periodic table is the mass of atoms, but there are some elements that exist as diatomic molecules. Finally, to go between moles and number of particles, there's this equality. Avogadro's number, which is 6.022 times 10 to the 23rd, particles in 1 mole. So this is what I mean about equalities can be made into two conversion factors. The equality to go from volume to moles is the 22.414 decimeters cubed of any gas equals 1 mole. Let's talk about neon. Here's the same equality for neon. That equality can make two conversion factors depending on whether you want to convert moles of neon to mass of neon, moles of neon to volume of neon, or volume of neon to moles of neon. Remember these two conversion factors. Both of them are derived from this one equality. The second equality on that mole diagram is X number of grams equals 1 mole. That's the molar mass, or the average atomic mass for atoms on the periodic table. Here is the molar mass of aluminum. That many grams of aluminum equals 1 mole of aluminum. Please note that I always write the number, the unit, and the chemical equals number, unit, chemical. You must be that thorough in the writing, the presenting of your work. Two conversion factors here for that equality. Likewise, the equality for number of particles and moles, two different conversion factors. Please note, number, unit, atoms, chemical, are necessary not only to set up the problem, but in every conversion factor. So this is how we're going to use the mole diagram. You're going to take I'm going to show you, the green circle is where you start. Let's say you're given a number of moles. If you want to convert that number of moles to the volume of a gas, that would be where you stop. You start here, you stop here, and you see you take the path that takes this equality. You're going to turn this equality into one of two conversion factors depending on what direction you're going, volume to moles or moles to volume. You can also start at moles and go to mass. And when you make this transition, you have to use the periodic table. Likewise on the bottom. So let's start here. I'm going to walk over to the whiteboard and start doing some problems with you. How many grams are there in 2 moles of oxygen? Well, first I'll go to the fact that you're given 2 moles of oxygen. You want to get to grams, which is mass. So here you are given 2 moles of oxygen. You want to get to the mass. So going back to the problem, first you write down what you're given. 2.00 mole of oxygen. Do you remember that oxygen is diatomic? Diatomic. Remember, whenever you have a diatomic molecule, there are 2 atoms hooked together. Now, I want to convert moles to mass. So I want to have mole on the bottom, 1 mole of oxygen. By the way, see, the abbreviation for mole is MOL. Look at the time you'll save. Now it's O2. So the periodic table says an atom of oxygen is 16 grams per mole. So this is going to be 32 grams of O2. Number unit chemical. When you multiply that, it equals 64.0 grams of oxygen. Number, unit, chemical, in your answer to correct sig figs. Number 3, to convert moles to a number of particles. Let's look once again at, if you're given moles and you want to get down to the number of particles, what's your conversion? To go from moles to number of particles, you use Avogadro's number. Here's the equality. So I'm going to save some time and tell you that. First, you write down what you're given. 1.50 moles of copper over 1. 1.50 moles of copper over 1. Then, this is the specific conversion factor to convert moles to atoms of copper. And your answer is given with number unit chemical and sig figs. Number 5, convert the number of particles to moles. Here we're going to start with number of particles. That means start green. Down here, we're going to start with the number of particles and convert it to moles right here. What equality do we use to start with particles and get to moles? Here's the equality. Avogadro's number equals 1 mole. So for number 5, you write down what you're given, 2.0 moles of helium. You start with what you're given. Now to convert moles of helium to volume of helium, gas at STP, you use the 22.414. It gives you your answer in liters of helium to sig figs. The following are 2-step problems. I'm going to show you these answers, but I don't want you to write them down. I want you to try them on your own. 2-step problems. The first one, excuse me, I paused just to cover up the answers while we're still learning how to work these problems. I'll share my screen again with you. So here we have a 2-step problem. How many grams are there in 7.55 times 10 to the 21 atoms of magnesium? So the mole diagram says that you are starting with a number of atoms way down here. You're starting with a number of particles, and they want you to end, red, with mass. Now, the only way you can go from number of particles to mass is through this middle step of the mole. So start at number of particles and go to mass. You have this equality to use as a conversion factor, and then when you get up here, you have this equality to use as a conversion factor. So you always start with what you're given. Write down 7.55 times 10 to the 21 atoms of magnesium. You might think that's a lot of atoms, but it's not very much mass. Then you convert number of atoms to mole. Then you convert mole to mass of magnesium. These are specific conversion units used by looking at the equality. You've got your answer to sig figs, number unit, chemical. Next problem. Number 3, you want to say how many atoms are in a volume of argon. So for this one, you're starting with how many atoms are in a volume. You're starting with a volume of argon. You want to tell them how many atoms are in that volume. You've got to go through the mole diagram. Volume using this to moles, down to particles using this. So this is done in very thorough dimensional analysis. You start with what you're given, volume of argon, just put it over 1. Then convert volume to moles of argon to number of atoms of argon, and there's your answer in number of atoms. I'm going to jump over any more of these. You can do them and get into your own practicing. Now this is on the homework sheet, and this homework sheet is just a smidge different in that I give you a different part of the problem. Number 1A on the homework sheet, convert to mass. If I give you moles of uranium, how do you convert that to mass? So I would do it right here. Just put that over 1. To convert moles to mass, I need the periodic table. I would say that 1 mole of uranium is 238.03 grams of uranium. There I have it. And the answer is moles to mass, 1.88 times 10 to the minus 1 grams of uranium. 2A. Nope, I don't think I'll do 2A. I don't have very much room for that. Down at the bottom, number 3, convert the following quantities to number of particles. If I'm giving you moles, number of particles is down at the bottom. So you use Avogadro's number. Here's the number you were given. That number over 1. Multiply 1 mole is 6.02 times 10 to the 23rd atoms, and you've converted moles to atoms. I should just show you one 2-step problem. Here you're given number of particles of fluorine, and they want you to convert it to volume of a gas. If you're given number of particles, that means you're green. You are down here to start. You are given number of particles, and they want you to find the moles, the volume of the gas. Starting with number of particles, finding the volume of the gas. You have to go through the mole diagram. You'll use this conversion factor to convert to moles, and this equality, to convert to volume of a gas. So, to simply show you the answer saves you and me time, but you have to work out some of these other problems. You write down what you're given. Number of molecules of fluorine. By the way, the abbreviation for molecules is MOLEC. Convert molecules to mole of fluorine. Did you remember fluorine is a diatomic molecule? and then convert moles of fluorine to a volume of a gas at STP. And you're left with number unit with chemical and significance. So this is the mole diagram. And I want you to try some more of your homework and check your answers in Schoology. This is a piece of cake. Try it. You remember dimensional analysis. Thank you for listening to this video. Don't forget to practice yourself to see if you're thoroughly doing your work. I'll see you tomorrow in class. Remember, I will not test or quiz on the homework check tomorrow anything about mole calculations, but it will be on atoms, ions, and isotopes, and a little bit of the history of atomic theory. Thank you.